Hello everyone, in this video I'm going to walk you through the free response question number 1 on the AP Precalculus Exam, and I hope that you're going to ace the AP Precalculus after watching the series of the video. Now question 1. The domain of the function f consists of the 5 real numbers 1, 2, 3, 4, 5. The table defines the function of f for these values. The function g is given by g of s equals 0.35 s cubed minus 3.5 s squared plus 11. The function h is defined by h of s equals g of f of s, and then this one is the composite function. Alright, so keep that in mind. Find the value of h1 as a decimal approximation or indicate that it's not defined. Alright, you must show your work that leads to your answer. So keep that in mind. This one is the calculator active. So even though you are allowed to use the calculator, you must show your work. So keep that in mind. Alright, now we need to calculate h of 1, right? And then the function h equals g of f of s, right? Now here's the answer sheet for free response question number 1. And then on the AP exam, you need to put your answer and your work in the designated area. So keep that in mind. Question 1a has I right here. Okay. You go back over here. You see I right here. You need to put your answer right here. Okay. Don't put your answer right here. Alright. So we have h of s equals g of f of s. Right. Now we need to calculate h of 1, right? So it could be g of f of 1, right? So it's going to be g of, now f of 1 is going to be 6 right here, right? So it's going to be g of 6, right? Now you look at the function g right here. G of 6, it could be this function right here, right? So you're going to copy this one over here. So it's going to be, print up the calculator. We just hit 0.35 times parentheses, set close parentheses. Alright, so the answer is, you must show your work like this to earn full credit. Question 2i. Find all values of s for which f of s equals 4 or indicate there are no such values, right? So f of s equals 4, it's going to be right here 4 and 4 right here. So you have two values, right? It's gonna be 2 and 5, right? So you need to write over here, right? You say f of s equals 4 when s equals 2 and s equals 5. Now question B. Find all values of s as decimal approximations for which g of s equals 5 or indicate there are no such values, right? So g of s equals 5, but g of s equals this function right here. So I copy this function over here. A lot of students make mistake. They're gonna do like this. This is wrong, right? You need to let this one equals 5. So keep that in mind. You have g of s equals 5. Then you have 0.35 s cubed minus 3.5 s squared plus 11 equals 5. Right? Then you're going to subtract 5 both sides, right? So you have 0.35 s cubed minus 3.5 s squared plus 6 equals 0, right? Now you're going to print up the calculator and you're going to solve this one, right? First you're going to hit add, graph, then you hit enter. It's going to be right here. Alright, now you need to adjust the window setting so that you're going to see the whole graph, right? So right here I hit menu number 4 right here. I hit number 1 window setting right here. Now as mean it's gonna be -10. That's good, right? But as mass right here, I just put 15 so I can see the right hand side of the graph, right? Now, for y min, I just put like negative 20. And then y maximum is going to be 20. And I hit enter. Alright, I still don't see the bottom of this graph, right? So I need to adjust the window one more time. Alright, menu, hit number 4, window setting right here. Y minimum right here, I need to put negative 50. Right, hit enter. It shows up, right? Now I need to find the zero, right? So I have 3 zeros right here. The first, the second, and the third one right here, right? So I need to hit menu, number, set, and number 1 right here. 0. Move your vertical line to the left of 0 right here. You see the 0 right here? Move to the left, hit enter, and then move to the right, hit enter. You get the answer right here. Now keep in mind, your answer should be at least 3 decimal places. If there are more than 3 decimal places, you just truncate your answer to 3 decimal places. So keep that in mind. So this is the first 0, right? Now the second 0, I'm gonna do exactly the same thing, right? Hit menu, number set, 0, move to the left, move to the right. I get the second one right here, right? Now for this one right here, I hit menu again, number set, 0, move to the left, hit enter, move to the right, hit enter. I get this one, right? So I'm gonna copy the answer down over here. So S equals. Now even though you're allowed to use calculator, you must at least show your work like this to earn full credit. Now question B2, determine the end behavior of the function cheese as s increase with down bound. Alright, express your answer using the mathematical notation of limit, right? Keep in mind, you need to read the question carefully and follow instruction, alright? They ask you to use the notation of the limit to write the end behavior. Alright, so go back over here, you look at the graph right here, right? When s approaches infinity, the function approaches positive infinity, right? Now I just copy the graph over here so that you can see it. It could be something like this, right? You just write this one is negative infinity, this one is positive infinity, this one is positive infinity, this one is negative infinity, right? So when s approaches positive infinity, the function going up forever. So which means it's go to positive infinity. So you need to write limit of the function g of s. Keep in mind this is g of s. This is not f of s. When s approaches positive infinity, the function approaches positive infinity, and that's it. Now you only answer what question asks you to do, right? Some students do like this, limit of the function g of s when s approaches negative infinity equals negative infinity. Don't do this one because the question doesn't ask you to do this, right? Question C1. Based on the table, determine if an inverse function of f can be constructed for all values in the domain of f, right? Show the function of f right here. Alright, now the best way to do this problem is sketch the new table, right? So I have the new table right here. So you have this one is s and this one f inverse of s. Alright, you just flip s and y right here, right? 1 6 becomes 6 1. Alright, 2 4 becomes 4 2. 3 0 becomes 0 3. 4 negative 1 becomes negative 1 4. 5 4 becomes 4 and 5. Alright. Now to answer this question, you just copy this one down. An inverse function of f cannot be constructed for all values in the domain of f. Alright, now C2. Give a reason for your answer in part C1 based on the definition of a function. and the table of values of FRS refer to the values in the table in your reasoning. Alright, so you look at this table right here. After you get the table right here, you see that the S value right here is repeating, right? Which means each output value right here is not mapped from a unique input value, right? Because f of 2 right here equals 4, right? And f of 5 right here equals 4. The inverse function on this domain does not exist, right? You need to say sin f of 2 equals 4. Then f of 5 also equals 4. Then you can conclude that each output value of f is not mapped from a unique input value. So the inverse function on this domain does not exist. The question number 2. Alright, question number 2 similar to question number 1. Now, given the table and given the function g of s right here, a1, the function h of s is the composite function of g of f of s right here. We need to calculate h4, right? So, we have h of s equals g of f of s, right? Now, we have h of 4 is going to be g of f of 4, right? So it's going to be f of 4 is going to be 5 right here, right? So it could be g of 5, right? Now g of 5, we need to use the function right here, s squared minus 2s plus 7 over s plus 5, right? 5 squared minus 2 times 5 plus 7 over 5 plus 5, right? So it's going to be 25 subtract 10, it's going to be 15 plus 7, it's going to be 22 over 10. So the answer should be 2.2, right? Now, question A2. Find all values of s for which f of s equal 10, right? So if f of s equal 10, we need to put the answer right here. F of s equals 10 when? Now we look at the table right here. F of s equals 10 when s equals 5, right? So you just put s equals 5 right here. That's it. Now move on to question B1. So B1 is going to be right here. Find all value of s as decimal approximation. So keep that in mind. For which g of s equal 4, right? So we just let s squared minus 2s plus 7 over s plus 5 equals 4, and we need to solve it. Now you need to find the domain so that this rational function right here is defined, right? So the domain, it should be s plus 5 not equals 0. So then s not equals negative 5, right? And then you just multiply both sides by s plus 5, right? So it could be s minus 2s plus 7 equals 4s plus 20, right? Subtract 4s and 20 both sides. So it could be s squared minus 6s minus 13 equals 0, right? So you have the quadratic function right here. You just use calculator to solve this one, right? So basically, you just hit Control I and hit add graph right here. You just put s squared. Now you hit enter, it's gonna be right here. Alright. Now you need to find 2 0 right here, the left hand side and the right hand side right here, right? So you just hit menu, analyze graph, and 0 right here. on the left and the right right here, it should be negative 1.69. And hit menu, analyze graph, 0. Move your cursor to the left of 0. Move your cursor to the right of 0. It could be 7.69, right? So you have two solutions. It could be s equals negative 1.69 and s equals 7.69. Alright, keep that in mind. B2. Determine the end behavior of function g as s decreases without bound. Express the answer using the mathematical notation of a limit. So we're going to bring up the calculator. We hit Control I. Alright, add graph right here. Alright, so we just input the function g of s right here. Then you hit enter. This branch is above the x-axis, right? Remember, we have the vertical asymptote when s equals negative 5, right? And then you have a slant asymptote right here, right? You have another branch, it's going to be on the bottom right here. It's right here, alright? Now we just get the graph into the answer sheet right here so that it helps you organize your thought, right? So it's going to be something like this. Now this is negative infinity, this is negative infinity, right? This is positive infinity, this is positive infinity. Now limit of the function g of s when s approaches negative infinity, right? Decrease without bound, right? So when s approaches negative infinity, the function approaches negative infinity, right? It's going down, right? So it could be negative infinity. Now let's move on to C1. Based on the table of values of the function f of s, determine if the function f is best modeled by linear, quadratic, exponential, or logarithmic function. Alright, so we look at the table right here. In order to get 1 from 2, I need to subtract 1, right? This one, add 1, right? This one, you need to add 3, right? This one, you need to add 5, right? Now, since the first difference not the same, so this will not be a linear, right? Next one, calculate the second difference. It could be plus 2, right? This guy plus 2 and this guy plus 2. The second difference are the same. So then this guy should be quadratic, right? Now to answer this question, we need to say the function f is best modeled by a quadratic function. Now C2, you need to say because the second difference in the output values are a constant 2 over consecutive equivalent input value intervals, a quadratic model is best. Alright. Now let's move on to the next question. Let f be an increasing function defined for s greater than 0. The table gives values of f of s as selected values of s. The function g is given by g of s equals 4.1 minus 2 times e to the s minus 6. Alright, we need to calculate the value of h of 3 given h of s equals g of f of s. This is a composite function as a decimal approximation. Alright, so we need to rewrite h of s equals g of f of s, right? Now we need to calculate h of 3. So it's going to be g of f of 3, right? And it's going to be f of 3. We look at the table right here. It's going to be 10. So you need to replace f of 3 with 10, right? So we have g of 10, right? Now we're going to look at the function right here. G of s equals 4.1 minus 2 times e to the s minus 6, right? Alright, so this is the calculator active problem. So we need to print out the calculator. So we just hit add calculator 4.1 minus 2 times e to the 10 minus it could be 4, right? And hit enter. It could be negative 105.096, right? Now look at the question A to I right here. Find the values of f inverse of 30. Or indicate that it's not defined. Alright, so we know that 30 is the input of the inverse function right here. Then it will be the output of the original function. The output of original function is to be right here. So the answer must be 12, right? So we need to write A to I right here. F inverse of 30 equals 12. Since F of 12 equals 30. Now let's move on to B, I. Find all values of S as decimal approximation for which G of S equals 1. Alright, G of S equals this one, so we let this one equals 1, right? So we need to solve this right here. So G of S equals 1 when 4.1 minus 2 times e to the s minus 6 equals 1, right? Now you need to subtract 4.1 both sides, so it's going to be negative 2 times e to the s minus 6. 1 subtract 4.1 is going to be negative 3.1, right? Now you need to divide both sides by negative 2. So it's going to be e to the s minus 6 equals 3.1 divided by 2. It's going to be 1.55, right? Now we look at the left hand side right here. We see that there is a base e, right? We need to eliminate this one so that we're going to bring s minus 6 to the front, right? In order to do that, you need to take natural log both sides, right? Remember, natural log is the same thing as log base e. Natural log of e to the s minus 6 equals natural log of 1.55, right? Now we're going to bring s minus 6 to the front, right? So it will be s minus 6 times natural log of e equals natural log of 1.55, right? Now natural log of e equals 1, so keep that in mind. Because this guy is the same thing as log base e of e, right? So log base e of e equals 1. Right, so this one turns out to be s minus 6 equals natural log of 1.55. So s equals 6 plus natural log of 1.55, right? And then you're going to use the calculator. Hit enter. The answer is 6.43825, right? So 6.438. Okay, you stop right here. This is good. Alright, keep that in mind. Your answer must be at least 3 decimal places, and you need to truncate your answer. Now let's move on to B to I. Determine the end behavior of G as S decreases without bound. I express your answer using the mathematical notation of a limit. Alright, the function G of S right here. In order to do this one, we just write over here. So we have G of S equals 4.1 minus 2 times e to the s minus 6, right? Now, limit of the function G of S when s approaches negative infinity. Now we just put this function on the calculator. So we hit Control I, add graph. Alright, it's going to be 4.1 minus 2 times e to the s minus 6, and we hit enter. It's going to be like this. And you see that this guy actually the transformation of the function e to the s, right? You shift up 4.1 units, so the horizontal line right here is 4.1. Asymptote is y equals 4.1, right? Now when s approaches negative infinity, which means s go to the function approaches 4.1, right? If we graph it right here, it's going to be like this. So when s approaches negative infinity, which means s go to the left, the function go up until 4.1, right? It's getting closer to 4.1. So this guy equals 4.1. Now let's move on to CI. So question C right here, use the table of values of f(s) to determine if the function f is best modeled by a linear, quadratic, exponential, or logarithmic function. Alright, so we look at the table right here. We see that in order to get 6 from 3, we're going to multiply by 2. In order to get 12 from 6, we're going to multiply by 2. This guy multiply by 2 and this guy multiply by 2. Now, for the y values, in order to get 20 from 10, we're going to add 10, right? This guy, we're going to add 10. This guy, we're going to add 10. And this guy, we're going to add 10. So, we need to answer this question. This is going to be a logarithmic function, because the input values of logarithmic functions change proportionally, right? As output values increase in equivalent intervals, right? So we need to answer CI and C2I right here. Now let's move on to the next question. Question D right here. Let f be an increasing function defined for all values of s, right? The table gives values for the function f(s) as selected values of s. The function g is given by 3 log base 5 of s. The function h is defined by h of s equal g of f of s. Now we need to calculate h of 4, right? We have h of s equals g of f of s, right? Now we need to calculate h of 4, which is g of f of 4, right? Now we look at the table right here. We have f of 4 is going to be 2, right? So it could be g of 2, right? Now we look at the function g. It's going to be 3 times log base 5 of s, right? So we just substitute 2 for s, right? So we have 3 times log base 5 of 2, right? And then we bring up the calculator. We just hit Control I. Then we hit Add Calculator. Now we hit 3 times log base 5 of 2. And we hit Enter. Right, it gives you exact value. You need to hit Menu, Action right here. Number right here, convert to decimal. Hit Enter. The answer should be 1.292, right? Now let's move on to question 8.2i, right? Find the values of f inverse of 2, right? So we look at the table right here. 2 is the domain of f inverse, and then it's going to be the range of the original function. So you need to find the values where f(s) equals 2, so it could be right here, right? So your answer must be 4, right? So you have f inverse of 2 equals 4, right? So we need to write the answer over here. F inverse of 2 equals 4, because you need to explain it. F of 4 equals 2. So keep that in mind. Now let's move on to BI. So it's going to be right here. Find all zeros of G of S as decimal approximation. Alright, so G of S equals 3 times log base 5 of S. We need to find 0, right? So we just say G of S equals 0, right? It's the same thing as 3 times log base 5 of S equals 0, right? And then divide both sides by 3, so it's going to be log base 5 of S equals 0, right? Now you just draw the arrow, so keep that in mind like this, okay? So you have S equals 5 power of 0, right? And then it's the same thing as S equals 1, because 5 power of 0 equals 1. This is your answer. Now let's move on to B2I. So it's going to be right here. Determine the end behavior of the function g as S increases without power. Express the answer using the mathematical notation of a limit. Alright, so in order to do this question, we need to graph this one. We either use the calculator or decimals, right? So I'm going to use the calculator. So I'm going to hit Control I. Add graphs right here. Alright, so I'm going to input the function g of S equal 3 log by 5 of S, right? So I have 3 log by 5 of S. Now I hit enter. It's going to be right here. Limit of the function g of S when S approaches positive infinity. So we look at this one right here. It's going up forever, right? So if you grab it, it's going to be something like this. So when S approaches positive infinity, the function approaches positive infinity, right? This guy goes to the right, this guy go up, right? So the answer is positive infinity. Alright, now keep in mind that y-axis is the vertical asymptote of the logarithmic function. Now let's move on to CI. Alright, so use the table of values for the function f of s to determine if f is best modeled by linear, quadratic, exponential, or logarithmic function. Alright, so we look at this one, we see that in order to get 4 from 2, we need to add 2, right? This guy add 2, this guy add 2, and this guy you're going to add 2, right? In order to get 2 from 1, we're going to multiply by 2. This guy multiply by 2, multiply by 2, multiply by 2. So the function f of s is best modeled by the exponential function, right? Because the output values of exponential function change proportionately as the input values increase in equivalent intervals, right? So we need to write it over here. Alright, so keep in mind the exponential function and logarithmic function, they are inverse. This one right here. The figure shows the graph of the decreasing function f on its domain of all real numbers where s not equal to 1. The points -1, 0, and 3, 2 are on the graph of f. The function g is given by g of s equals 2 plus 3 natural log of s. The function h is defined by h of s equals g of f of s. We need to find the value of h of 3, right? So we have h of s equals g of f of s, right? Now we need to calculate h of 3, right? H of 3 equals g of f of 3, right? Now we look at the function f right here. F of 3 is going to be right here. The answer must be 2, right? So you have g of 2, right? Now you substitute 2 for s into this equation right here. G of s equals 2 plus 3 natural log of s, right? So 2 plus 3 natural log of 2. Now we're going to bring up the calculator. We just hit 2 plus 3 natural log of 2. So hit enter. Now you need to convert it to decimal, right? So we hit menu, number, convert to decimal, hit enter. The answer 4.079, right? So it could be 4.079. This is the answer. Now question A2I. Find all zeros of f, right? The function f right here. Zeros means the s-intercept, right? So we look at this one right here, it's actually right here. So s equals -1, right? So we need to write over here f of s equals 0 when s equals -1, right? Now we're gonna move on to bi right here. So question B right here. Find all values of s as decimal approximation for which g of s equal e. So the function g of s right here. Right, so we have g of s equals e. It's the same thing as 2 plus 3 natural log of s equals e, right? Now we need to subtract 2 both sides, so it could be 3 natural log of s equals e minus 2, right? Divide both sides by 3, so you have natural log of s equals e minus 2 over 3, right? And then natural log of s is the same thing as log base e, right? So we just write log base e of s like this equals e minus 2 over 3, right? Now you just draw the arrow like this, right? So you have s equals e raised to the e minus 2 over 3, right? Now we just bring up the calculator. So we have, now you're gonna hit enter. Right, so it's gonna be exact value, right? You hit menu, number, convert to decimal, hit enter. The answer is 1.270, right? So it could be 1.270. Now let's move on to B2I. So determine the end behavior of the function g as s increases without pound. Alright, so the function g is going to be 2 plus 3 natural log of s, right? So we just print up the calculator, we grab this one, right? Hit Control I, add graphs right here. Now we just input the function, so it can be 2 plus 3 natural log of s, right? We hit enter, it's going to be like this, right? So we're gonna grab it over here so we see it, right? So it's gonna be something like this. This one is positive infinitive, this one is positive infinitive, this one is negative infinitive, and this one is negative infinitive, right? Now, as increase without bound, right? So when s approaches positive infinitive, the function keep going up forever, right? So we have limit of the function g of s when s approaches positive infinitive equals positive infinitive, right? Now let's move on to C, I, and C2I, right? Determine if the function f is invertible, right? So the function f is given by right here. Give a reason for your answer in part C(I) based on the definition of a function and the graph of the function y equals f(s), right? So we look at this one right here. We see that the function f is definitely invertible, right? Because you just use the horizontal line test, you will see that, right? Alright, the common mistake students mostly do is to say that the function f passes the horizontal line test. Right? If you write like that, it's not sufficient, so don't write that one. We just use the horizontal line test to identify if the function is invertible or not. Right? But you don't write it over here. Right? Keep that in mind. Right here, you need to say each input value of the function f is mapped from a unit input value, right? So that the function f is invertible. So keep that in mind. Now let's move on to question f right here. The function f is defined 0 less than equal to s less than equal to 9 and consists of 3 line segments as shown in the figure. The function g is given by g of s equals sq plus 3s minus 23 over s minus 1. Now we need to find h of z, where h of s equals g of f of s, right? So we have h of s equals g of f of s, right? Now h of z equals g of f of z, right? So we look at this one. F of z is going to be 1 right here, right? So this one is the same thing as g of 1, right? Now we need to use the function g is given by this guy right here, right? So it's going to be 1 power of 3 plus 3 times 1 minus 23 over s minus 1, which means 1 minus 1, right? So this one is the same thing as negative 19 over 0, right? This one is undefined. Whenever you see denominator equals 0, the fraction is undefined, right? So remember that if you have 3 divided by 0, this one is undefined. If 0 divided by 3, it's going to be 0, right? If you see 0 divided by 0, it's going to be undefined. So keep that in mind. So you need to answer this one. You need to say h of z does not exist. Or you can say h of z is not defined. Now let's move on to question A to I. Alright, so question A to I right here. Find all values of s for which f of s equals negative 2. Alright, so f of s equals negative 2 is going to be right here, right? So you have two values. The first one is going to be 2. The second one is going to be 9, right? So you need to say f of s equals negative 2 when s equals 2 and s equals 9, right? Because f of 2 equals negative 2 and f of 9 equals negative 2, right? Now let's move on to question B, I, and B to I. Find all values of s decimal approximation for which g of s equals 7.2, right? So g of s equals 7.2, we let this one equal 7.2, right? So we have g of s equals 7.2 is the same thing as s cubed plus 3s minus 23 over s minus 1 equals 7.2, right? Now, in order to solve this one, since we allowed to use the calculator, right? So we just separate this one into two functions. This guy is the same thing as y equals s cubed plus 3s minus 23 over s minus 1. And the second function is going to be y equals 7.2. And we need to find the intersection between these two graphs right here, and that's the answer, right? So we're going to print up the calculator. We just hit Control I, right? Right here. Okay, so we're going to put s cubed plus 3s minus 23 over s minus 1, right? Now you hit enter. It's going to be right here. Alright, now you need to input the function y equals 7.2, right? So you need to hit tab right here. Alright, 7.2. Hit enter. Alright, it's going to be right here, right? Now the intersection should be right here, right? So you need to hit menu number, sit right here, analyze graph, and intersection, right? So it should be right here, right? So you move to the left, you hit enter, move to the right, hit enter. The answer should be right here, 3.06, right? So it's gonna be s equals 3.06. Determine the end behavior of the function g as s increases with down bound, right? Now we look at the graph right here. We're gonna sketch this one over here. We see it. Now this is positive infinitive. When s approaches positive infinitive, the function going up forever, right? This is positive infinitive, right? So you need to write limit of the function g of s when s approaches positive infinitive equals positive infinitive, right? Now let's move on to question Ci and C2i. Determine if the function f is invertible. Right? Give a reason for your answer in part Ci based on the definition of a function and the graph of y equals f of s. Right? Now, in order to do this question, we need to use the horizontal line test to test to see if the function is invertible, right? So we just get the horizontal line. We see that there is two intersections right here, right? Right here, you see that two intersections right here, right? So the function f is not invertible, right? Function f is not invertible, right? Question Ci right here, you need to say because each output values of the function f is not mapped from a unit input values, right? Because you see that f of 5 equals 0 and f of 8 equals 0 right here, right? Now let's move on to the next question. Question G. The figure shows the graph of the decreasing function f on its domain of all real numbers s, right? The points -1, 10, and 3, 5 are on the graph of f, right? So the points right here and right here. Now, the function g is given by g of s equals this one. Question ai and a2i. The function h is defined by g of f of s. We need to calculate h of 3, right? So we have h of s equals g of f of s, right? Now we need to calculate h of 3. It's going to be g of f of 3, right? So it's going to be g of, we look at the function f here. F of 3 equals 5 right here, right? So it's going to be g of 5, right? Now we need to input 5 for s into this function g right here, right? So we have, alright, so we just bring up the calculator. We hit Control I, hit Add Calculator, and we just input this one, right? So it's going to be, now hit enter, the answer is -2h1.02, right? Alright, now we're going to move on to question A2i. Find all zeros of the function f or indicate there are no real zero, right? So we look at the function f right here. It's above this line right here. This guy actually the horizontal asymptote, right? So it's keep going like this. Right? So you need to answer this question is, so you need to answer the question A to I. There is no values of S such that f of S equals 0, right? Alright, now we're gonna move on to question B, I, and B to I. Find all values of S as decimal approximation for which g of S equals 10. Alright, so the function g of S right here, and we let this one equals 10, and we solve it, right? Now this guy is the same thing as intersection between two functions. The first function is going to be y equals negative 1.9 s power 4 plus 6.8 s cubed plus 12s minus 3.52. The second one, y equals 10, right? So we just print out the calculator. We just input these two functions on the graphing calculator, and we need to find intersection, right? So we're gonna hit Control I and hit Add Graph right here, right? So it could be negative 1.9 s power of 4. Now you hit enter, the graph should be like this, right? Now the second equation should be y equals 10, right? So you need to hit tab 10 and hit enter. Alright, you need to extend the window, right? So you need to hit menu, window zoom right here, window setting right here. As maximum, as minimum is good, right? Now, but y minimum is good, but y maximum right here. Because y for 10, right? So you need to put like 20 right here. Hit enter. Alright, so the graph show up right here, right? Now you have two intersections right here. These are solutions to the system of equation right here, right? So you need to hit menu, number 6 right here, and number 4 right here, intersection. The left hand side, move your cursor to the left, hit enter, move to the right, hit enter. You get this one right here. The first intersection, 0.855, right? Now hit menu again. Number 6, intersection, move to the left of the second intersection. Move to the right of the second intersection. It's going to be right here, right? So you have two solutions, 0.855 and 3.877, right? So S equals 0.855 and S equals 3.877. Now let's move on to question B to I. Determine the end behavior of the function g as s increases without bound, right? So in order to do this question, we're going to look at the calculator right here. We see the functions right here, but it's not clear enough, right? So when you graph it, it's going to be something like this. Alright. Now you see that when s approaches positive infinity, the function keep going down forever, right? It's go to the right right here, negative infinity, right? So you have limit of the function g of s when s approaches positive infinity equals negative infinity, right? Keep in mind, don't write like this. S approaches negative infinity, f of s approaches positive infinity, right? If you write like this, it doesn't count because the question wants you to use the limit notation, right? So keep in mind, it's going to be right here. Now let's move on to CI. Determine if an inverse function of f can be constructed for all values in the domain of f, right? Now we look at the function f right here. We just use the horizontal line, right? So we see that every single times the horizontal line intersect the graph as only one point, right? So it does have the inverse function, right? So you need to write the answer right here. An inverse function of f can be constructed for all values in the domain of f. Now, in order to explain this one, we need to say that each output values of the function f is mapped from a unique input value, right? Don't say that the function does pass the horizontal line test because it's not sufficient, right? We just use the horizontal line test to help you figure out if the function has an inverse or not. That's it. But don't write it on the paper, right? Now let's move on to the next question. The last one right here. Question H. The function f is defined for -5 to 5, right? And consists of 3 line segments as shown in the figure. The function g is given by 5.4 minus 0.79 times 2 to the 1.3s. Now, given h of s equals g of f of s, we need to calculate h of -1, right? So, AI right here, we have h of s equals g of f of s, right? Now, h of -1 equals g of f of -1, right? It's gonna be g of, now f of -1, it's gonna be right here. -2, right? So it could be g of -2, right? Now we need to substitute -2 for s into this function right here, right? So we have 5.4 minus 0.75. Alright, now we just bring up the calculator, hit Control I, hit Add Calculator. Now it's gonna be 5.4. You're gonna hit Enter. The answer should be 5.269, right? Now let's move on to question A to I. Find the values of f inverse of 1, right? So in order to find f inverse of 1, we need to look at the value of s equal 1 right here. S is the domain of this function, and then it becomes the range of the original function, right? So we look at y equal 1 on the original function, right? So it's going to be right here. The value should be right here. So you have f inverse of 1 equals 2, right? So you need to write over here f inverse of 1 equals 2 because f of 2 equals 1, right? Now let's move on to question B, I, and B to I. Find all real zero of g, right? So the function g is right here. So we need to let g of s equals 0, right? So we have g of s equals 0 is the same thing as 5.4 minus 0.79 times 2 raised to the 1.3 s equals 0, right? So because you're allowed to use the calculator, you just use the calculator to find the answer, right? So we need to put this one on the calculator. Hit Control I, add graphs right here. So it could be 5.4, and you hit Enter. It's gonna be right here. Now what you need to do is to find the zeros of this function, right? So it's gonna be right here, right? So you need to hit Menu, Analyze Graph, hit 0 right here, right? So you need to move your cursor to the left of 0, hit enter, move to the right, hit enter. The answer is 2.133, right? So s equals 2.133. Now question B to I. Determine the end behavior of the function g as s decreases without bound. Alright, so we look at the graph right here. We see that this is the function g, right? It's start from 5.4 right here, right? So actually y equal 5.4 is the horizontal asymptote, right? So the graph should look like this. right? And the horizontal asymptote is 5.4. Y equals 5.4, right? Now, when s decreases without bounds, which means negative infinity right here, s go to negative infinity, the function go up and getting closer to the horizontal asymptote 5.4, right? It never passes y equals 5.4, right? So you have limit of the function g of s when s approaches negative infinity equals 5.4. Now let's move on to Ci and C2i. Determine if the function f is invertible and give a reason, right? So we look at this one right here. We use the horizontal line test to check, right? So every single time you draw the horizontal line test, you see that only one intersection, right? So you need to say the function f is invertible, right? Now you need to give a reason, right? So we look at the graph here, we need to say that each output values of f is mapped from a unique input value, right? Don't say because the function passed the horizontal line test. Don't say that. Okay, keep that in mind. So right here we need to say f is invertible, right? It's your time to start. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings as the chemicals they take us higher. The night's young and it's just begun as she puts her hand in mine.